I also want to just say the next speaker here, Ernie Iverson. You ready to go, Ernie? Ernie's going to talk about using AviSynth or AviSynth or whatever you want to call it.
I call it AviSynth, but it's whatever you want to call it, I guess. What I want to talk to you about today is I think we're going to trade places if that's the right presentation. Here we go. I want to talk to you about how AviSynth can be useful in occultation work, but you'll notice that the subtitle is Ways to See More. As astronomers, we always want to see a little bit more. And sometimes we give up because we don't see enough. And that's what I want to hope to fix. I realize that many of you out there today are probably more familiar with AviSynth and how to use it than I am. But let's go ahead and we'll go through this for those of you who don't, and it's a review for those of you who do. This was my second positive occultation that I ever recorded. And the reason I show you this is because I originally reported it as a miss. And granted, this is a little further back and a smaller screen than I was hoping for, but you take a chance when you prepare a slide, and you know, you never know what you're going to have as a screen. When I was at the SAS meetings earlier this year, they had two huge screens, and it was totally different. Anyway, the object of this one is that you're not supposed to see it, because I didn't see it. Next slide, please. These are my two recording devices. I have a number of the Canon ZR cameras illustrated on the left there. And if I have an opportunity, I love to use my Sony Video Walkman. You notice that the screen size is about 2 inches for the ZR and about double that for the Sony. Still small screens, still hard to see things. Next slide, please. So the first thing you can do is try a larger screen. And that's actually how I did find the occultation, is I played it back, you know, I single frame stepped back through it, and I was actually looking at it on a 14-inch monitor. But you know what, a lot of these modern TVs, you can plug your AVI, composite AVI into it, and that's a real nice way to find things. And I guess it's a little small, but actually you could see that if in the right situation, you could see it. It's there on his display there. Next slide, please. So why do we want to use AviSynth? First of all, what is it? It's a powerful tool for post-processing recorded video. It's used extensively in animation. There are a number of, well, I'm getting ahead of myself. It works as a frame server. It provides an instant edit on the entire movie or video clip. That'll come into play in a minute when I talk a little later. And you don't need to go through a lot of temporary files when you're doing this. It kind of instantaneously knows what you're doing. It's fast. But unfortunately, instead of having a GUI interface or a good user interface, you have to do it all by script files. But actually, it's not that hard. It's just a couple of mouse clicks to make a change. And then you have to run the script again, and it works. And next slide. One of the first issues, though, is you have to have iMovie be able to read a AVI file, and as was pointed out earlier, at least in the older versions, it didn't do it. Could not handle the digital video that we get from our composite, from our ZR cameras, or in my case, the Sony Walkman. When you record the tape, it's recorded as audio, as composite, which is audio, analog, is what I'm trying to say. It's only when you use your FireWire interface to bring it into the computer that it gets translated into digital. And once it's in digital video, then you start to have problems. iMovie, as was previously mentioned, only can see video for Windows, and of course video for Windows doesn't include a digital video codec. But if you use Direct Show Source, it does. And Direct Show Source is using Microsoft Direct Show, as was mentioned previously. And the old way of getting around this problem was you had to use virtual dub, and that took time consuming, and you had to create extra files and back and forth, and it just wasn't good. What I've found is, and I should have checked this before I put this presentation together, my version of iMovie automatically opens up a AVI script file for me. It creates it, very simple one-line file, and it may be that just because I've already put in the plug-in for it, I'm not sure if that feature comes with the original kernel or not. Anyway, next slide, please. This is going to be very simplistic for most people, but just for clarity, make sure we're all on the same page. I use Notepad to create the script file, and then down at the bottom there, when you type in the name, you just type .avs, and you have it as a .text file, and it'll go ahead and create the appropriate file with the right file extension. Next. Did we miss one? Okay, my mistake. All right, if you select the AVI file in the iMovie screen, it'll open up the script file, and there's an example of a simple script file there above it. Next slide. First thing you want to do, up in the top there, you see I've enlarged that first line a little bit. You want to make sure you're in the right directory. A lot of times I'll wonder, well, what's going on here? And I find out, well, I'm not in the right directory. And then the gotcha that I wanted to tell you about is you need to select the correct file. And you see there that there is a one line there for Lorelei, and then a date. That's actually the file that's automatically created, because if you click on that's the video file. If you click on that video file, it will then create that AviSynth file for you. Just to open that, it won't let you do anything else, and you can get hung up there. So instead, what you want to do is go to the bottom, and if you click on the line there on the bottom, go ahead, next slide. In the middle there, you can select file type AVS, and you want to do that. Next slide, please. Then you can double click on that one, It'll wind up on the line on the bottom there, and then you can go over and click open, and you should find your video opening up. Next slide. Oops. What happened? Next slide, please. When you get what I call the black screen of death, it's always been a problem with the path, file name. And if you'll notice, I left out _pause, and it'll catch you every time. I've also noticed that if the file, the path name is too long, it tends to object. So you don't want to get overly generous in how you describe where you're keeping these files. Next slide. All right. In the script file above, you can see it's direct show source, and then the path to that particular video. Probably the simplest script function is just the info. And it's not real useful, but it does have a couple of things. It'll illustrate a couple of things. First line says frame, and it says 0 to, in this case, it's 1039. So here I am, I'm sitting at the beginning of the video, and it already knows what the end is, where the end is, how many frames there are. So that's why I say it works on the whole entire file, the entire clip. Next, it gives you time, but that time is just a, based on the frame rate. It's not a very good time. By the way, that the frame number is also the same frame number you find in line moving. That's displayed in line moving. Below that is color space. That's interesting because now it tells you how your data is packed into color space, which gives you a clue as to what your codec could be. There are more variations to video than we've all got fingers to toes for. There's just dozens and dozens of variations. And if you don't have the right one, the right codec, it will not play. And it's not only, the video, sometimes it's how they pack the color, how they, the order that they pack the bits in. It can be also deal with the audio. And you'll notice that down there it calls out the audio. It says there's 2 channels. Well, gee whiz, my camera doesn't have a microphone attached to it. But as soon as you recorded it on that Canon ZR, you did. And that's what causes it. That takes up file space. A little bit above that, though, let's see, it tells you the size, the aspect ratio. That can be interesting, and also gives you a frame rate. Frame rate can be interesting because not all cameras are created equal. For example, the image source cameras can give you a variable frame rate, and you really don't know what it's doing. I've used it in double star work for some of what I've been doing, and I've actually gone back and found that, hey, wait a minute, I thought it was doing 60 frames a second or 30 frames a second, and no, it was down at 7. So, something useful to know. Of a little more use, next slide, is the DB info function. This is what they call a plug-in, and AviSynth has 2 sorts of modules or functions, subroutines. Those have the internal ones, which are in the kernel, which come with when you get the program, and then there's these that have been developed in the user group, and those are plugins. And you have to get this from this particular one from what is it? Warp Enterprises, I guess. Is anyway. The email address is up there. But it's far more useful in the bottom there. You notice it gives you time and date. This is the time and date that is extracted from the header that was put on your tape by the Canon ZR. And this is actually how Scotty came up with these stamp and run program for procedure for multiple stations. And what you do is if you record a short segment before you deploy the station, and that can even be the day before you deploy it, and then after you pick it up again, you now have the ability to figure out what the drift in the crystal in that internal camcorder clock was. And from that you can figure out what your exact time should be. Also, it gives you a way of checking to see if you've got dropped frames or if it's added frames. Go ahead, next slide please. Let's see, I've said most of that. Just note that I use Kiwis. I've got 3 of them, so everything I present is based on a Kiwi and not the VTI. Next slide please. This isn't perhaps that useful for occultation work, but it's something that you need to be aware of. This is the function lens cones resize. Turns out that when you digitize the analog video to digital, and then as you move it through your system, each step of the way it handles things a little bit differently. There's different conversion ratios and factors, and there's slight changes. You don't really see that unless you're looking at, say, like double stars. And even if you're looking at close double stars, you won't see it. It's only when you look at widely separated double stars that we first notice this as a problem. So, also, our video cameras and most of the video equipment we use is designed for the commercial market, not for occultation use. And people like to see nice wide screens, so 720 by 480 is not uncommon. Next slide please. So for my system, this is based on using double stars that have exhibited little or no movement over the several decades. I've figured out that I should resize the screen to 640 by 465. This is something you do once and it's good until you change the cameras or you change telescopes. But with that setting, with that aspect ratio, it closely matches. I know that it closely matches what the sky is. Now for occultation work, this isn't real useful because we use time and we're not too concerned about distance. But I want to point it out to you because it's something you might not normally think about. Next slide. Level filter. This one is very useful. First of all, it acts as a gain control. It also allows you to sharpen the contrast and thereby reduce noise. And third, it doesn't have a time penalty, and I'll explain that later. Next slide, please. Okay, my formatting didn't work out, even though I tried to fix it last night. There are 6 arguments. You only need to mess with 2 of them. The first is input low, and then the third one is input high. Gamma there is the second one. You can change that to allow you to see stars easier, but gamma encoding is used to optimize the way the human eye takes advantage of, is used to take advantage of how the eye perceives light and it's in a non-linear fashion. I recommend you just set gamma to 1 and leave it alone. You really don't need it, because by the time I'm finished, we're going to drive the ability to see things to absurd levels, and we don't even have to use gamma. All right, next slide, please. The last term there was coring. Coring refers to the range of pixels and their luminosity, or the grayscale, and the color value of in the frames. In the CCIR 601 television standard, the range of values, the black is set at 16 and full white is at 235. However, if you set coring to 0, you get the full range, which is 0 to 255. So again, just leave coring set to false and be done with it. Next slide. So how does a filter work? There on the left, you'll notice that I've got in green there a hypothetical signal. If you were to set the input low to 20, that line there, everything below that line, which includes most of the noise, is set to black. And likewise, if you set the input high to 100, you've gotten rid of most of that space on top is set to white. And at the output stage, you notice that the signal gets stretched, thus making it easier to see your target star. And most of the noise has been eliminated. You notice at the top I do 255 minus noise. That's simply for linearity. You don't really need to do that. Next slide, please. Okay, here's some examples. We've switched occultations now. This is in Loreley. On the left there is how it would look without any enhancements. Probably looking at the 3D renderings at the bottom will be more useful than trying to find the image in the background in the video screen. You can see the target and a nearby star. And then when I set the upper level to 100 on the right side, you can see that they have significantly increased. The smaller of the two is actually the target star. You also notice that the noise level has gone up some, the background level. It acts on everything the same. And as a result, the background of if we had at my angle, the video picture is pretty washed out, so I can't tell if you're seeing it or not, but it's a little lighter. All right, next slide. On the left, that's the same as the slide on the right on the previous. On the right-hand side, now what I've done is I've increased the noise. And you notice what happens is all of that noise there has disappeared. Yes?
Okay, so Ernie, I'm not sure if you're going to advocate clipping that noise out or not, but I'm going to advocate that you don't, that you always would set noise at 0, because in our modern day analysis of light curves, we use the noise level to establish what the error bars are going to be for the observation. And we need the noise to be accurate and not clipped off.
Okay, point taken, but wait for my very last statement.
Okay.
I got you covered. I got you covered. My focus, was from the very beginning was that, hey, here was this occultation I thought I should have had and I never saw it. Well, I'm trying to fix that problem in people's minds. Just because you don't see something doesn't mean that it's not there on your tape, you didn't see it. These are ways to see it. You'll notice in this presentation I've been very careful not to talk about timings, to try to say, well, this is how you decide your time and stuff. I've avoided that for a reason. So anyway, let me go on. Anyway, you notice that it's very clear and you can see clearly see it. Next slide, please. And that's just a light curve. It looks kind of pretty. Okay, it's the value. The settings are such that you get a nice dip down. It looks pretty. It's probably not the best one. Probably not one that Tony would appreciate. But anyway, next. You definitely know that you had an occultation if you saw that. Next slide. Well, you learn something new every time you do things, and with the 3D graph on the right, there's a box there that you can set a moving average. Well, if you set that moving average, it works only on that 3D graph. And it's useful because all those ugly little spikes and what have you in the noise, it's hard to find your star. So it's an aid in smoothing things out, but it doesn't get translated into the CSV file. However, on the iMovie screen there on the right hand side, I've got two arrows. One points to, I believe it says more, and if you click on that, another little box pops up and it gives you an opportunity to select the moving average again. This time if you select that moving average, it will affect what goes into the CSV file. I didn't know that before. Next slide, please. The next thing I want to talk about is the add 3 function. It was written by Steve Preston. It can combine 3 frames, 5 frames, or actually any number that you want to, if you just follow the basic format. And how it works is that random noise is and signal build together, but since random noise is random, it doesn't build quite as fast. And therefore you can see your target star easier. And it can also be used with the level filter, and I'll do that in a minute. And one of the functions that are used in it is the overlay, and it has a lot of different features. You can blend frames together, you can subtract them, you can just add the luminance quality of it, you can lighten and there's a lot of things you can do with it. Subtract might be somewhat useful because if you wanted to calibrate your videos, this is the starting point for that. And I would refer you to the IOTA meeting minutes from 2008 where Robert gave us presented a good presentation on calibration. But anyway, the add 3 function is, or add 5, however many you want to use it, essentially duplicates what's happening in an integrating camera. Next slide. This is just the code. There's a lot there. It's an eye chart, so we're going to skip it. Next slide, please. How it works in a nutshell. If you assume you've got a 12-frame video clip, the video clips are always numbered, the frames are numbered from 0 to whatever. The first function that you would have encountered is the frame count, and it just picks up the total number of frames. And then there was a trim function, so he uses that 3 times to get 3 different videos, and it trims. The trim returns a clip. In the first case, from 0 to 9. The second case, from 1 to 10, and then 2 to 11. So they're staggered by 1. And then time code is clipped out of the original. Now to put it back together again, you use something called overlay, and it puts the one clip into the base clip, and then finally you add what's called clip in there into the result. You've got all 3 clips back together. You overlay time back in again, and then the last function there will return a new video n-3. And I think in Steve's presentation, and that's found in the IOTA documentation online, it's n-1, and you'll see why it should be n-3 here in just a second. Next slide. So this is what happens. You can see this is the original eagle occultation. You can see that this is not using any kind of a script file to get this, and you see that there's a tiny little target star there. Next slide. Using add3, you can see how the target star is quite visible now. You may or may not see it in the center of that circle. Also notice that the background has also increased. It's lighter, but remember that the randomness of the noise, it's not adding as fast. So, but it is still there. All right, next slide, please. And this is add 5. As expected, the target star is easier to see. In fact, I can even see it from this angle. And you see that the background is quite a bit noisier. It's quite a bit lighter. And where I put time back in again, you can obviously see the difference. Next slide. Now, how to go to absurdity. If you combine that with the level filter, in this case I set noise to 40, or the 0 level to 40, and the upper limit I brought it down to 55, and then I used the add 5 filter. We drove both signals into to where they're clipped. So you can just do all kinds of, that's why you don't need gamma. You got more gain here than you need. Next slide, please. But there is a timing penalty. So here's a little experiment to find out what's going on. First thing I did is I found a occultation that was bright, had bright stars. I intentionally set the contrast very high so that in one frame I would see the target star, and the next frame it would be gone. No question about it. It's there or it's not, okay? Because I wanted to use that as a marker. Next slide, please. Okay, on the left-hand side, if the function is not used, you'll notice that the frame is 116. It was the last frame that it was seen in, and you'll note the time there, milliseconds. Then on the right-hand side, I have applied the add3 function and gone back to that same frame, and there again you can see that in both cases it's the last frame. The star is visible and then it's gone after that. But it serves as a marker, and the time codes are the same. Let's go to the next slide. Here's what appears to be happening. Remember, we offset the 3 video clips that we're going to add together by successively by 1. So the red line there is when you've got 3 clips that have the target star. Then the green is there's 2 clips. The blue is there's only 1 clip. And then finally the purple is no clips. And so that's why you see in frame 116, which is the frame that I'm currently pointed at with, stopped at it with live moving, and that's the one that it's giving the time code back to me from. And the reason you want to have at the end, when you bring it back, you want n-3 is because really those last 3 frames of the video are useless because they're not complete. And that's why n-1 works, because no one looks at the last 3. You never notice it. But technically, to be correct, it probably ought to be 3. So next slide.
I would just mention, I think what you're talking about, where it's affecting your timing, is that the function is actually integrating the video. And therefore, in the frame before the occultation, the middle frame, when you're adding 3, you're adding in the next frame, which has the occultation, which is going to reduce the brightness of the middle frame that you're integrating it into. And that's going to affect your timing.
I don't disagree.
Okay, so now we have this issue with integrating cameras. And it isn't necessarily a problem for timing if we use a program such as Ocular or Arrow, which incorporates subframe timing, and will look at the height of that data point and interpolate the exact time where the occultation occurred correctly. So it can be a timing issue if you're doing it visually off of your light curve, but it doesn't have to be a timing issue if we use other programs that will compensate for that.
Wait for my last statement. Remember, this is why I did this little experiment, because I wanted to find out what the effect was, and I didn't like what I found. So anyway, this slide here basically just shows that we're collecting time from the original video, which is, as you say, what we're integrating there. So next slide. What's the cost in time? This is without taking into consideration any camera delays or anything like that. It's just a simple comparison that the point I want to make is that with the AviTech, which is the camera that I use frequently, with a setting of S1, it's 60 or 30 frames per second. And S2, you combine 2 frames. S3, you're combining 4 frames. And then finally, S4 is 8 frames. And you can see the time resolution that you get up from that. And if you're using a non-integrating camera, say, like the PC-164, but you did use the post-processing integration with the add 3 or add 5 functions. In add 3, you can see that it's only about 1/10 of a second. And also with add 5, it's 0.165. So you do get a gain which kind of approximates what you could do with a true integrating camera. And that's the only point there, is that for people that have non-integrating cameras, you really can do something like integration, but at the post-processing level. Next slide. Now I want to talk about the magnify function. This is one of the problems that iMovie has is if you've got two bright stars or you've got a dim star very close to a bright star, you can have the aperture ring jump over to the bright star, and that's really not a good thing when that happens. And I haven't tried it yet, but I kind of suspect it might be useful with lunar occultations also. And that's one, there are several versions of how to do this. This is one that I found out on the web. Next slide, please.
What are you saying it would be useful?
It might be. I haven't tried it.
What might be?
To magnify, this will illustrate what I'm talking about. On the right-hand side there, since I don't have a good example of an occultation, I had to go and use a double star, and actually this is one that Richard recorded and gave to me for this presentation. You can see that there's two stars that are, 4.5 arc seconds apart. If you do a 2x magnification on it, what happens is your points of interest start separating the two stars. There at the very bottom though, you notice that there's a bridge or smearing between the two stars. And this is what gives iMovie a difficult time, and it will slide over to that bright one if you're not careful. And with 3x there, it's even farther. But if you were to combine that with, let's say, the level filter, then you could raise the floor a little bit, and you could track that object very easily. So that's what that's all about. Yes.
Okay, so the premise is that sometimes when you have two stars close together, when the one disappears, the aperture will pop over to the other star, and that's very true. So an alternative in iMovie is you set two apertures and you link the primary star to the secondary star, and then when the primary disappears, it won't jump over, it'll stay linked to the secondary where it's supposed to be, and then when it pops back on, the star will be in the right aperture. So
that is entirely true, but I'm considering the case where there's two really close together and it can still jump over.
no, when you link them in the second,
No, I'm not talking about linking. Okay, we're talking about two different things.
I understand, but I'm saying that's how you avoid the problem. If you set a secondary star and
I realize that.
primary, it won't jump. But you have to set drift to off or anchor to off, and then it won't jump. You make the one directly linked to the secondary, it won't budge unless the secondary moves. And then you solve that problem. Just a suggestion.
Not it.
Yes, there are a couple ways to solve the problem.
Yeah.
Exactly, yeah, just trying to make sure that people out there in video land don't go off in an adjunct direction here when there's maybe a simpler solution.
My topic today was to talk about AviSynth and not how to use iMovie.
That's okay.
But I'm aware of what you're saying, and it does work, and I might take issue with you on in a couple of situations, but in general you are very right. You're correct. That is a good way to do it. Next slide, please. Okay, the point I was trying to make today is just because you don't see something in the occultation you went out and went through the cold winter night to collect, doesn't mean you don't have data. Remember that second occultation I did, I reported as a miss. But then I went back and looked again and, did a little different way, and I found it. So I really had an occultation there. If you experience time code issues, it can probably be fixed. And especially if you recorded a little bit of time before and after. Obviously, the level filter significantly increases the visibility of a target star by increasing the brightness, and the level filter also significantly sharpens the contrast while reducing the apparent background. Next slide. The add 3 function, add 5 functions are useful to further increase the signal noise in post-processing. But of course you do have a time penalty that you have to pay that's not present in the level filter. But it's still a useful method, especially if you're using a non-integrating camera. And I don't know how visible the red is in the last statement there, but it basically says that from this direction anyway, it's kind of washed out. If you're going to use one of these functions or scripts to enhance your video, you really want to submit a version of that video to either Tony or Brad and let them look at it with a more modern program, because what I've tried to show you today is just ways to find out that you really did have an occultation, because if you've got an occultation, they'll tell you all the particulars about it. And there's another hidden point to that, and it's good to have standardized data reduction. Especially when we start, archiving data, that it's important that things are done the same way. So, next slide. That's just my 14-inch scope. On the bottom there, I've got a wide field video camera that's got a TV lens on it. Gets me in the right part of the sky. Then I use an 80 millimeter to actually star hop with, and then I find what I need in the main telescope. Questions?
Yeah, a question from Ted Swift. With the DV info time, is it lost during transfer over the firewire? I think that's the camcorder time that you were talking about. And he says, I think I've turned info on in the ZR, but when I run the AviSynth script, I'm not able to get the time to show up.
First thing you need to do is make sure you've got a good lithium backup battery in your camera. That's not the main battery. This is that tiny little button cell that is hidden away. That's what's used to keep track of time, to power the time circuits. Then you need to set time. And once you've got time set, then that is actually encoded into the AVI header. And that AVI header is in the analog, really. And it gets, when you digitize it, it gets carried across. So, next question. Anything else? Thank you.
Thank you, Ernie. It's amazing how much you can extract from seemingly lost videos by that type of post-processing. And AviSynth is a very useful program in a lot of other ways as well.